Okay, so Joachim takes part in 2 cycle races. Probability he wins the first race is 0.6, so therefore the probability does not win is 0.4. Okay, remember on a tree diagram that for each part, so here's one part here, both these things are going to add up to 1. And Joachim, the probability he wins the second race is 0.7, so he doesn't win, is 0.3. They're independent events, so therefore we get that. Right, fairly easy in that case. Just remember that each part needs to add up to make 1. Find the probability he wins both races. So, probability he wins both races is going along here, then along here. And so that's 0.6 times 0.7, okay, which is 0.42. Pretty straightforward so far. Okay, he then takes part in a 3rd cycle race. Alright, the probability that Joachim wins the 3rd race is 0.2. Work out the probability he wins exactly one of the 3 races. So, we've got, and I can't unfortunately go back to look at the tree diagram. It doesn't work with this software, unfortunately. So, the ways he can do that is he can do win, lose, lose. He could do lose, win, lose, or he could do lose, lose, win. And if we work out all the probabilities of those and add them together, we should be all sorted. So this is 0.6 times 0.3 times 0.8. This is 0.4, and you can use your tree diagram, alright, to do this. There you go. And this one is 0.4 times 0.3 times 0.2, work them all out, which is, what is it, 0.144, I've got 0.224, and this one is 0.024, add them all up, and you'll get the probability of 0.392. Now, if you make a mistake and you get an answer that's more than 1, you must know you've made a mistake, because you can't have probabilities that are greater than certain, if you know what I mean. So there you go. But just set it out logically, and like I say, I always say to people, list out all the ways you can get what you want, and that's what I've done here, and then I can put the probabilities in later.